Hello, welcome to Bodhana. As part of lecture series, in this video, I am going to discuss about the importance of nanomaterials as part of JNTU unit number 4. Coming to the syllabus point of view, the total syllabus is divided into the three parts. The first one, introduction or origin of nanotechnology. How this science related to the nanotechnology is established. What is the origin? What is the source? What are the features for the nanomaterials? What are the speciality for the nanomaterials? Why we are showing that much interest for the nano region of materials compared to the bulk materials? Is there any difference between these two? That part we need to discuss as part of part 1 related to the nanotechnology. And then obviously we have a doubt. If that much importance is there for nanomaterials, how we can prepare that materials? Is we need to follow a different kind of methods to prepare the materials or like a bulk materials? Definitely we are using different kind of methods to prepare the material with nano size. Here the nano is nothing but like a word related to the 10 power minus 9, like intermediate units and measurement length point of view, we use the word like nano, deci, centi, milli, micro, nano, pico, femto, atto. Here the word is nano is related to the 10 power minus 9. Here also the same, the material in which dimension 10 power minus 9, that can be taken as nanomaterials. For example, which dimension? For example, some cases in only one dimension it might have 10 power minus 9, or some materials may have the in 2 dimensional it may have the nano range, or some materials we may have the all 3 dimensions are in the nano range. For example, I'll show just an example. If I ask you, so what is the structure of this material? We can simply say that it's like a cuboid which have the 3 dimensions. All the 3 dimensions are above the considerable range. It is not at all nanomaterials. For example, when I ask you about this, so just we'll think about the length and breadth. We won't think about the width, because as a width comparatively length and breadth it is negligible. Then we can simply say that it is a 2-dimensional material. When you take in this way, it's not like this way. So then obviously we consider the length is very high as compared to the other parameter, then we can say simply it is a 1 dimension. But really it is not. But we can simply it is a 1, it is a 2-dimensional, and it is a 3-dimensional material. Reality is here nanomaterials is nothing but in any 1 dimension. If you take a length, width, height, or any dimension, if the size is around 10 power minus 9, that material is considered as the nanomaterial, and depends upon the things. If all the sides are in nano, we can take it as like a point, like a quantum dot. If only 1 dimension is in the nano, then we can say that like a sheet. Or if 2 dimensions are in the nano, then we can call it as rod or wire, etc. If there is no dimensions are in the nano, then we can call it as bulk materials. Then coming to the properties point of view, these properties are completely different because of different approaches. For example, this material has surface area is more compared to the volume compared to the bulk material. As you know that if the surface area is more, then obviously it can be used as a catalyst, or it can be used for different application, because more reactive is there, more surface area compared to the volume, then obviously it has very special material compared to the others. Quantum confinement, energy band gap values are different compared to the bulk materials. A random walk nature and weak gravitational forces. So there are several parameters point of view. Nanomaterials are different compared to the bulk. Because of that, nanomaterials grab the attention of researchers for different approaches. Coming to the preparation point of view, this take it as the part 2, how we can prepare the nanomaterials. There are different approaches, bottom up and top to down. The word itself bottom, this is down to up, that is Up is like a nano range. Now we are taking the material lower than a nano to nano range. That means that bottom to up stage. This is generally chemical synthesis method like sol-gel, precipitation, co-precipitation, etc. All these what it is, combustion method, all these methods are under the category of the like a bottom up method. These are just some examples, but we have different approaches to prepare the nanomaterials, but syllabus point of view we have limited. But top to down approach, in house generally we use like a granules are crushed into the powders by using the mixie, right? The similar way, when you crush the bigger granules into the smaller, that is called as ball mill approach. Bigger size is crushed into the very small particles, that can be taken as like a ball milling method. CVD, chemical vapor deposition. PVD, physical vapor deposition. PVD and CVD both are almost similar, except the starting material is solid form in PVD. The starting material is in the chemical form in the CVD. So these are the different approaches to prepare the nanomaterials, but this is the last one. I quote that I prepare the nanomaterials. I just prepare the nanomaterials, but no one will agree without proof. That's what we need, some proof related to that particular material, whether it is structural, whether it is morphological, etc. If the structural point of view, intermediate chemistry, crystalline and amorphous, regular arrangement and the irregular arrangement, that part, whether it is crystalline or amorphous, if it is crystalline, CTOT, HMT, cubic, tetragonal, orthorhombic, monoclinic, hexagonal, triclinic, etc. That crystalline, which crystal it belongs, that part is decided by measuring the lattice parameters and angle between the axes. That part will be possible by taking the X-ray diffraction technique. Short form is XRD. That part is one of the most crucial and important characterization tool for nanomaterials. And then surface morphology, whether it is a spherical morphology, whether it is a regular morphology, whether rod shape or cylindrical shape, what is the exact size, that part is there in case of SEM, scanning electron microscopy, and the transmission electron microscopy. Coming to the scanning, the surface is scanned by the electrons, that is the scanning electron microscopy, and another one, the electrons are transmitted through the sample, that part is there in case of the transmission electron microscopy. These two are related to the microscope. We know that in school days we used to see the microscope for the small bacteria or something else. There we use the optical light as a source, that is the optical microscope. Here our intention to see up to 10 power minus 9, because of that the light is not suitable. That's what we are taking as the electrons as a source. In the first unit, like a quantum mechanics, we discussed that electron is also behave like a wave, as like light. That's what. So electrons used as a source to see the very small object. This is about the characterization tool as part of syllabus, but we have different. If you want to check whether it is a magnetic or not, we can use the vibration sample magnetometer. Whether it is optically present or not, we use the UV visible spectra. Whether the elements are present or not, EDS. There are several approaches. Whether it is a dielectric or not, we can measure the dielectric constant. So there are several approaches to check whether the material is related to the particular application or not. These are general characterization point of view. According to the syllabus, we are using the XRD, SEM and the TEM. And then last one, applications. There is no limitation for the application. Nanomaterials can be used for different application. Cosmetics, medical, drug delivery, agricultural, because it has more surface area, right? It can stick on the leaves. There is a possibility of agricultural application, industrial application, technological application to reduce the size of the device without changing the performance. So this is about the just some examples related to the nanotechnology or the nanomaterials, and the complete theory related to the nanotechnology topic wise will be discussed in the upcoming videos. Thank you. If you are new to here, I am Dr. Ramesh. Please subscribe.